Okay, this one is number theory. I think this one I have explained to you. Number theory is about the integers, and also their properties lah. For example, we have divisibility, modular arithmetic, mode, greatest common divisor. Later we discuss this one. And then we have also least common multiple, LCM. Okay. And then we look at some relevant algorithm. The relevant algorithm basically to calculate the GCD and also for calculating the LCM. Okay, and then we look into the prime and greatest common divisor, GCD. Okay, for the prime numbers, for the prime numbers is the number that have only two factors. First one is you can divide by themselves. For example, the first five prime numbers are 2, 3, 5, 7, and 11 lah. Okay, this is prime, and for the prime number, it's a natural number that greater than 1. That is not the product of two smaller natural number lah. And then a natural number greater than 1 is not a prime number. It is called as a composite number lah. For example, 5 is a prime because the only way of writing as a product is 1 multiplied by 5 and 5 multiplied by 1 lah. This one. Okay. This prime number. Other than prime number, we call it as a composite. Composite, for example, 2, we have 4, we have 6. Okay. Okay, and then division. Division I have explained. If A and B are integers with A is not equal to 0, we can say that if A can be divided by B, if there is an integer C, so B is a product or is equal to A multiplied by C. Lah. For example, if 3 can be divided by 12, 12 is equal to 3 multiplied by 4. And then 3 multiplied by 4 is an integer. Uh, okay, A is a divisor. Okay, 3 is divisor. And B multiple of A is dividend. B is dividend. And 0 is a remainder. Okay, and then please bear in mind for the factor A, C, and B. Okay, we can look for the remainder. The remainder must be 0. And then for 4 can be divided by 27, the answer is no lah, because the okay, this one is not integer. This one is a real number. Okay. Okay. For another example, we have fact or divisor. Okay, 3 can be divided by 27. Yes lah. Okay. 3 can be divided by 25 by dividend. No lah, because we got 8.3333. It's not an integer. It's fine. It's not an integer lah. And then we have a remainder 1. Okay, and then also 3 cannot be divided by 25 lah, because we can say if there is an integer, it is must be an integer lah. Okay, because this one is product of 27. Okay, is equal to 3 multiplied by 9, and this one must be an integer lah. Okay, and then for the divisibility theorem, especially for integer a, b, and c, it's true that 3 can be divided by 6 and 3 can be divided by 9. So 3 can be divided by 15. Okay? If a can be divided by b, then a is a product of b, c. B, c. Please be reminded that c must be integer. This one of all integer c. 5 can be divided by 10, so 5 can be divided by 20. 5 can be divided by 30. 5 can be divided by 40 lah. Okay. Okay, and then if A can divided by B, and B can divided by C, then A also can be divided by C lah. Okay, this one is same lah. Okay, 4 can be divided by 24 lah. Okay, so far do you have any question? Ada soalan ke? Ada. Kalau tak, if you not understand, you can ask lah. Okay, and then the division algorithm. Okay, D is called divisor. A is called a dividend, Q is called a quotient, and R is called a remainder. Okay, A dividend is equal to D divisor multiplied by Q quotient plus R. Later we see this one. Okay, and then for divisor is D, A is dividend, Q is quotient, minus DQ. Okay, and then we have R is a reminder, and then R is less than or equal to 0. R is must be less than D. D is a divisor, and R, this one must be positive. Okay, R must be positive. Okay, and then note that the remainder cannot be negative. What happened when we divide that negative 11 by 3? Okay, 11 negative 11, okay, is equal to 3 multiplied by negative 4 plus 1. As you can see, 3, 11, okay, negative 11. Okay, we divided by negative 4 is 12. Okay, negative 12, negative, got positive, and remainder is 1. Okay, okay, and then find mode 17 mode 5 and find 1300 negative 133 mode 7. Okay, this one divided dividend negative positive. Okay, for the positive, you can see this one is positive. Positive. Okay, and then for the dividend negative, okay, this one is negative lah. Okay, negative dividend. Okay, we have a divisor. Q is quotient and R is remainder. R. Okay, and then negative 11 is a dividend. Okay. Okay, this one is when we did 17 by 15, we can get, okay, 5 by 17. 5 multiplied by 3, 15. We have 2 plus 2 here. And then 17 is dividend. 17 is dividend. 5 is divisor. 3 is called quotient. And 2 is called the remainder. Okay. Okay, this one is modular arithmetic. if a is an integer and m a positive integer, a mod m is a reminder when a is divided by m. Okay, this one is example divided. Okay, okay, exercise this one, please go for Padlet. Okay, and then for application for module arithmetic, I think this one I have explained last week. Okay, for today, we got prime and greatest common divisor section 3.5. For natural number, I have explained. Other than that, we can call it as a composite. Okay, P is greater than 1 is called prime. Only positive factor of P and are P and 1. Okay, this one is the writing it as a product. Then the fundamental of theorem of arithmetic, every positive integer can be written uniquely as the product of prime, where the prime factors are written in order of increasing size. Okay, for example, we have a prime factor, 3, 5, and then we have 48, here 48, 2 multiplied by 24, and then we got 2 multiplied by 12, and then we got 2, again we disseminate 2 multiplied by 6, 2 multiplied by 3, and then we got 1, 2, 3, 4, 2 power of 4 multiplied by 3, okay, 3 power of 1. Okay, and then 17 is 17. Okay, this one you list out the order of increasing size, the order lah. And for 100, we got 2 power of 2 multiplied the 5 power of 2 lah. Then 512 is 2 power of 9 lah. And last one 28. Okay, we have 2 power of 2 multiplied by 7 lah, 28. Okay, then we got 2 power of 2 multiplied by 7. Okay, for the this one we call it as a prime factorization. 2 power 4 multiplied by 3 is we call it as a prime factorization. Another example is 72. For please list the prime factorization. For example, the question asks you to list the prime factorization for 72. You should do like this. 72, 4 multiplied by 18, 2 multiplied by 2 multiplied by 3 multiplied by 6. Then last one you got 2 power of 3 multiply 3 power of 2 is equal to 72. Whereby the 2 power of 3 is equal to 8 multiplied by 9 is equivalent to 72. Prime factorization is a way of expressing number as a product of its prime factor. A prime number is a number that exactly has have two factors. One is the number itself. For example, if we take the number of 30, okay, later we see that one. And then for 48, we got 8 multiplied by 6, and then we got 4 multiplied by 2, 2 multiplied by 3, and then we got finally 2 power of 4 multiplied by 3 power of 1, is equivalent to 48. Okay. Okay, another example. I give you another example. Okay, please. Okay. Sometimes we call it as a prime decomposition. Okay, prime factorization. Sometimes we call it as a prime decomposition. Okay, and then for example, we have 864. Okay, equivalent to 32 multiplied by 27. Okay, and then 32 is can be divided by 4 multiplied by 8. 27 3 bukan multiply by 9 lah. And then this one 2 multiplied by 2. 8 is 2 multiplied by 2 multiplied by 2. 3 is 3 lah. Okay, 3 is 3. Okay, and then 9 is 3 multiplied by 3 lah. And then we got 2, 1, 2, 3, 4, 5, power of 5, multiplied by 3, power of 1, 2, 3 lah. Is equivalent to 864. Okay, do you have any question? Is it okay? Boleh ke? Okay. Prime factorization juga dikenali sebagai prime decomposition. Dia ada sama je, dia punya, it is the same. Okay. Kamu kena composekan dia, kamu kena factorizekan dia untuk uh, untuk dapat ni lah. Okay, dalam exam nanti kalau ditanya ataupun ditanya sebagai integer factorization, kamu kena buat macam ni lah. Okay. Any integer can be factored into its constituent prime factors by repeated application of this algorithm lah. Okay, and then for the prime is the composite integer, then n has a prime divisor less than or equal to power of n. It is easy to understand. If n is composite integer, it must have two divisor. We have P1 and P2 such that P1 multiplied by P2 is equivalent to n, and P1 is greater than or equal to 2, and P2 is greater or equal to 2 lah. And P1, another condition is P1 and P2 cannot both greater than the power of n because then P1 multiplied by P2 would be greater than n. Okay. If the small number of P1 and P2 is not the prime itself, then it can be broken up into the prime factor that are smaller than itself but must be greater than 2. Okay, this one is greatest common divisor, GCD. Okay, the greatest common divisor is denoted by GCD AB, and then for the notation, GCD A, comma B is equivalent to D. Okay, what is GCD for 48 and 72? Okay, the positive common divisor for 48 and 72 are, this one we list out. Yang ni kita gunakan penyenaraian ataupun dipanggil sebagai listing. 1, 2, 3, 4, 8, 12, 16 and 24. So for the GCD 48 and 72 are 24 lah. Okay, yang ni yang GCD greatest common divisor yang paling besar lah. Okay, then this one is for the listing. Listing for the GCD we can have several methods. First one we call it as a listing. Second one we call it as a factorization. And number 3 we call it as a repeated division. Okay, for example, if we take a look for the listing 24 and 36, 24 we got 1, 2, 3, 4 we list. we list, kita listkan. And then for the 24 and 36, we got 12. Okay. Then for the factorization, same. This one I explained before. We list out. We list out the prime factorization or decomposition. 2 multiplied by 2 multiplied by 3 is equivalent to 12. Okay. And then finally you got 2 power of 2 multiplied by 3 power of 1 is equivalent to 12. Okay, and then for GCD 10 and 45, okay, you can use this technique also. Okay, you have 45 and 5. This one is QR, quotient, quotient, and R is a reminder. Okay, 10. Got 4, 40. Then we got reminder 5. Okay, this one reminder 4 is a quotient. This one is a divisor D. Okay, and then uh, okay, we have a 10 here. Okay, and then we go again. 5, 2 is 10. We got 0. Yeah. Okay. GCD for 1001 and 3768. Same, 171. Okay, is a divisor. Okay, we have quotient. Okay, okay, and then this one is dividend, and R is a reminder. Okay, then here we goes again, 376 multiplied by 1701, we got 237. So this one goes here until we got the reminder. Okay, 129, 21, and so on. Okay, 108, 21 multiplied by 5 plus 3 until we got a reminder 0. Yeah, or you can use the repeated division. Repeated division for 2 multiplied by 2 multiplied 3 by 3 is equivalent to 12. Okay, this one for GCD and LCM, this common multiple, we have a division operation, we have a prime factorization, and then the last one we got Euclidean algorithm for the division operation. Okay, we can have a D for the divisor. Okay, and then okay, for this one, for the GCD 48 and 72, we got 2 multiplied by 3 multiplied by 4. Here we for the LCM, this common multiple, M multiple, we got 2 multiplied by 3 multiplied by 4, and then the remainder also we calculate, and then the answer will be 144. Okay, this one for the prime factorization number 2, number 2 here, number 2 prime factorization. For the GCD, we got 24 and 144. For the GCD, we choose the minimum, minimum 2 power of 4 multiply by 1, 3 power of 1 2 power of 3 multiplied by 3 power of 2 lah. And then for the minimum, 2 power of 3 is minimum lah. 2 power of 3 multiplied by 1 is 24. And then for the LCM, 48, we calculate the maximum lah. For the least common multiple, we choose the 2 power of 4 multiplied by 3 power of 2. This one maximum. Maximum mean the highest number lah. Okay, and then the answer also 144 lah. Okay, for the greatest common divisor, using the prime factorization, we can compute, we can calculate by using the prime factorization. For example, we got the GCD 60 and 54. Okay, this one we list out the prime factorization, and then we choose the minimum. Minimum is 2 power of 1. And then minimum 3 power of 1 minimum. And then 5 power of 0. And then we got 6. 2 power of 1 is 2. 3 power of 1 is 3. And then 5 power of 1 is 1. Okay. 5 power of 0 is 1. Okay, and then find GCD for 120 and 500. You should write in a Padlet. This one, please upload your exercise in Padlet. Okay, so far, do you have any question? LCM and GCD, is it okay? Okay, Shafi, okay guys, Shafi. Daniel, okay, Daniel. Yeah, and then least common multiple LCM. Yang ni tadi saya dah bagi tahu, kita kena cari dia punya positive integer, yang smallest positive integer, and that is divisible by both A and B lah. Okay, contohnya LCM 3 and 7 is equivalent to 21 lah. Okay, is dia punya ni lah, dia punya common multiple this common multiple we got by the M lah. Okay, then for 4 and 6, okay, 4 and 6 we got 12 okay. Okay, for the LCM, okay, by using this thing, we got 12. By using a prime factorization, okay, we got 12. By using the division method, we got 12. Okay, for the least common multiple, okay, we choose the maximum. Okay, for A, prime factorization, 60, 2 power of 2, 3 power of 1, 5 power of 1, and then we choose 2 power of 2. It's a maximum 2 power of 1. And then we choose 3 power of 3 and 5 power of 1, and then we got 540 because we 4 power of 2, 2 power of 2 is 4, multiple by 3 power of 3 is 27, and multiply by 5. Then we got 20 multiplied by 27 is equivalent to 540. Okay, and then find the LCM for 120 and 500. You go by the Padlet. Okay, same goes to here. Find the greatest common divisor for these pairs. Okay, and then we got the relatively prime integers. Okay, by the definition, is searching for two integers a and b are relatively prime if GCD b is equivalent to 1 lah. Okay, for example, if 15 and 28 relatively prime, yes lah. 55 and 28 relatively prime, yes. 35 and 28 relative prime, no lah. The GCD for 35 and 27 are 7 lah. And 17 and 22 are relatively prime, yes lah. Okay, another example, is it 7 and 9 is relatively prime integers? Yes lah, because we got 1. Okay, for 8 and 10, no lah. 8 and 10 no, because we have 2 1, 2 and 1 and 2 same. Okay, 3 and 36 relatively prime, yes lah, because we list out 1 only 1. Okay, and then 24 and 36 relatively prime, absolutely no lah, because we have 1 2 3 more than 1. Okay, kalau kita tengok 28, 15 and 28 also 1 lah, and 55 and 28 also 1. Okay, 15, 28. Okay, we have 1, we have 14 Huh, bukan 4. Bukan, siap. Dia punya ni, dia punya tu 4 kali 7, 3 kali 3 9, 4 kali 7 lah. Okay. 4 kali 7 28 147 lah. Jadi yang kita ada kat sini 1 dengan 1 je lah. Kan? 1 lah. Okay, 35 and 28 bukan lah. Okay. 35 and 28 bukan lah. Sebab apa? Kita ada 1, 5, 7, 1. Ada 2. Ada 2. Okay, and then GCD untuk 35 and 28 bukan relatively prime integers, because the GCD ada 2 yang kita nak cuma ada 1 lah. Boleh dia nak 1 je. Okay, yang ni GCD 8 and 10 no lah. Okay, 8 and 10 because we got 2 1, 2, 4, 8. Okay, this one 1, 2, 5, 10. Okay, 31 and 36, yes lah. We got 1, 2, 3, 4, 6. Oh, dia mesti prime prime number. Yang tadi bukan prime number. 1, 4 bukan prime 1 and 7. 1 and 7. Sorry, this one is not the prime. Prime must be cannot be divided by 2. 1, 7, and then we got 1, 5, 7. Okay. Yang tadi tu this one 1 and 7 only. 1, 7. 1 and 7 only. 2, 4 it's not a prime. Okay. Okay, 24. 1, 2, 3, 6. 6 bukan prime. 1, 2, 3 lah. Yang ni pun 1, 2, 3. GCD 24 and 36 is 3 lah. It's not a prime, a relatively prime lah. Okay, and then relative prime number, prime integers. Uh, if GCD A1 AJ is equivalent to 1, is equivalent 1, less than 1, less than J, less than N. Yang ni kalau kita ada 3, kita comparekan satu-satu, we comparing one by one. Uh, 15 and 17 first, and then 17 and 27. Is it the relatively prime integers? No lah, because 15 and 27, we got 1, 3, we got more than 1 lah. Okay, 15 and 17, yes lah, because we got 1, 3, 5, 1, 17, only 1 only 1. 15 and 28, 1, 3, 5, 1, 1 and 28 can be divided. Can be divided for a 3. 1 only lah. This one 1 only. 1, 7, 1 and 7 relatively prime, not common except 1. Except 1. Okay, and then for this 17 and 28, also we got 1. 1, 17, and then this one got 1, 2, 7, and 28. Only 1. Okay. Okay, for 7, 10, 17 and 21 pairwise relatively prime ni ada 3 Jadi buat dekat Padlet lah. Same goes to this one. Okay. Okay, this one the relationship between GCD and LCM. For GCD we choose the minimum. For LCM least common multiple we choose the maximum lah. Okay, that's why we got 540, and then this one we got 6 lah. Theorem is A multiplied by B is equivalent to GCD AB multiplied by LCM AB lah. The theorem A multiplied by B, this one multiply, we got 3240. This is equivalent to LCM 6 multiplied by 540. We got the same result. So the Excluding algorithm is to find the greatest common divisor of two integers A and B. Okay, if you want to find the GCD 287, 91 we divide 287, the large number, by 91, the smaller one. Okay. Okay, then we got 91 multiplied by 3. Okay. Got 14, the remainder 14, the remainder. This one is coordinate. Okay. And then this one we got smaller one. Smaller is 287 minus 91 multiplied by 3. Okay, we got this one, either 91 multiplied by 3 or 91 we divide multiply by negative 3. Therefore, any divisor of 91 is also divisor of 91 multiplied by negative 3 because we want to choose the smaller one. Okay. Okay, and then for the Euclidean algorithm, we know as for the integers a, b, and c, any divisor A, 287 and 91 must be also divisor of 287 plus 91 multiplied by negative 3, which is 14. 14 is the remainder. And then for GCD 287, 91, the GCD is 14 uh, and 91. Okay, B plus C. Okay, in the next step, we divided 91 by 14. It means that GCD for 14 and 91, we got 14 and 7. So we divide again 14 by 7 until we got the remainder is 0. So we find that 7 divided by 4, thus GCD 14 7 is equivalent to 7. So the GCD for 287 is 90 and 91 is 7. Okay, the minimum, minimum, the lowest. Here is another example. Give 2,875, 4,915 for the Excluding algorithm. Okay, this one is large dividend, small divisor lah. Okay, we calculate until we got the 5, and the remainder is 0, and then this one is the lowest. Lowest is we calculate as a 5. Okay, for the division algorithm, its remainder is 0, and last divisor GCD. Um, okay, last divisor is equal to GCD. Last divisor, this one. Okay, this one is the last divisor. Okay, this one is a breakdown for GCD 2,875 and 4,950. Okay, another example I give to you. Saya bagi contoh yang lain. Okay, buat sekejap yang ni. GCD untuk 807 dengan 481 dapat berapa? Buat sekejap. Okay, 807. Okay, we got 16 multiplied by 9 plus 11 plus 5. Okay, and then the final one we got 1. It's equivalent to 1. Okay. So, okay, boleh ke ikut? Another example saya tunjuk lagi contoh lain supaya kamu faham lagi Sebab ada yang apa-apa nak clear sangat. Kalau contoh GCD for 662 412 equal to okay, 662 equal to 4 414 sorry 4 multiplied by 1 is plus 248 414 is equivalent to 281 and 248 multiplied by 1 is plus 166 166 182 to 82. Okay, then the smallest we got a 2 lah. Okay, yeah. Okay, GCD 6 or 1 4 GCD 414 248. Okay, boleh kita cari yang paling kecil lah yang ni. Okay, and then for the Excluding algorithm, we got the LCM and GCD. For the LCM, okay, for the least common multiple, okay. For the theorem, 2875 multiplied by 4195 equivalent to 5. We use this theorem, A multiplied by B is equivalent to GCD A B multiplied by LCM A B lah. And then for this one, we divided by 5 lah. Okay. We search for GCD here first. Then we got multiplied by 5, we got 2 million and 127, 125. Okay, this one for GCD 448 and 72. Okay, we divided lah by the using the theorem A multiplied by B and GCD AB multiplied by LCM AB. And then here we got 48 multiplied by 72 is equivalent to 24. Okay, multiplied by LCM 48 72 divided by 24. Okay, 24 here. Okay, we search for the GCD first and we divided in the theorem. Then we got 144 lah. Okay, this one Excluding algorithm, GCD 2875 and 915. This one, the last divisor is a GCD, continue until the remainder is 0. So the GCD for 2875 divided larger. Uh, for the divisor smaller, we got 5 lah. Okay, this one I have explained to you. Okay. Okay, same goes to GCD divisor and dividend. We got 111. Find the GCD first, and then you divided the using the theorem. Theorem A multiplied by B is equivalent to GCD AB multiplied by LCM. This one GCD here you divide. Okay. Same goes here. Same goes here. 111 LCM 1221 14430. It's equivalent to GCD 1221 multiplied by 144,030 divided by 111. Okay. Okay, so far, do you have any question? Boleh ke? Kita cari dulu GCD dia, dia punya values dia. Lepas tu kita divide lah dengan GCD untuk kita cari kita guna theorem untuk kita cari dia punya LCM. Okay, another example, find the greatest common divisor of 414 and 662 using the Euclidean algorithm. Okay, is 2 lah. It's a minimum. Okay, because it is the last non-zero reminder lah. Okay, and then let A B Q plus R, where A B Q R must be integers. And GCD AB is equivalent to GCD BR, can be done using computational programming as shown next slide lah. Okay, this one is pseudocode. Okay, we have a GCD AB must be a positive integer, and then we initialize x equivalent to A, y equivalent to B. Okay, while y is not equal to 0, begin lah. Okay, the syntax is modulus like this. This one for multiple, this one for power, and this one for divide. Okay, for the exercise, use the Euclidean algorithm, find 12 and 18. Okay, for the use in a Padlet, and then please be reminded that the this last non-zero reminder, last non-zero reminder here, you got 0, and then you got the reminder. For example, 1221 14430 divided, we got 111. And then for the LCM, we got multiplied by 111, we got 1 million. 587,030 lah. This one, Bizot theory is application of number of theory. If we have A and B are positive, there exists S and T such that GCD A B is equivalent to A, T and B. Yang ni kita nak tengok dia punya guessing number lah. Kita nak guess number apa yang kita nak bubuh. Contohnya kalau kita ada kat sini 111 S 1221 plus T 14430. Okay, yang ni kita nak guess lah S dengan T ni berapa. Jadi kita guess 999 minus 222 multiplied by 4. Okay, and then kita buat calculation macam ni. Okay, lastly kita akan dapat untuk 5 ni 55 negatif 4 4A negatif 54 minus 4A. This one is the guess. Okay. Okay. Bizot teori ni another example. Sekejap saya cari. Okay, sometimes we can call it as a Bizot identity lah. Formula dia AX plus BY is equivalent to D lah. In general, the integer of form AX plus BY are exactly the multiple of D lah. Okay, for example, we have 40 and 64 is equivalent to A. Saya buat surat baru lah kot. Tak nampak. Okay, example simple 40 before into A. Okay, and 64 by 40. Okay, and then step 9. 38 1 multiplied by 60, and then berapa? 8. Dua apa? Betul, 2 kali 8 tambah kosong. Tapi yang ni kita nak buat, kita nak D. Kita nak tengok D, dia punya D tu 8 ni extended je. Kita tambah 8. Lepas sekejap. Satu kali 16 tambah 8. 2 kali 8. Okey, betul. 2 kali 8. Setelah 2 kali 8 tadi, silap saya. Pening dah. 2 kali 8 tambah kosong lah. Okay. Okay, yang ni yang kita tengok GCD biasa lah. Yang ni GCD. Okay. Jadi GCD yang ni kita dapat 2 kan. Tapi untuk Bezout identity ni, sekejap. Okay, jadi untuk Bezout identity, we got 40, 64. Kita ada 8. Plus. Dan total 4. Jadi Bezout identity untuk yang ni kita dapat 2 dengan 3. So we got Bezout identity. Okay, macam mana dapat ni? Kita tengok 24 sama dengan 64 tolak 1. Okay. Kita dapat 16 40 tolak 1 dah nak 24. Kita dapat 8 4 tolak 1 dah nak 16. Okay. Jadi yang ni kita namakan dia sebagai result identity lah. Kita nak guess. Okay. 2 dengan 3. Okay. Sama juga macam ni lah. Okay, ni nombor besar sangat. Besar sangat. Result identity S and T. S and T. Kita nak guess. S and T 111 S and T 999 equivalent A plus 4A is equivalent to 5A lah. Sekejap, saya calculate dah eh. 94 darab okay. Yang ni diganti terus dia buat pergantian terus for A, and then we got 5 and 59 is the result identity lah. 111. Okay. And then this one result identity saya rasa tak masuk dalam final lah. This one untuk kamu punya ni lah, sebab dia kira coefficient untuk apa? Untuk nombor GCD tu. Yang ni exercise tolong buat dalam ni Padlet. Ini ada jawapan ni lah. Okay. Yang ni kalau result identity example 4 and 16 we got 4. Okay, this one 4 multiplied by 5, 20. Okay, and then we got 16 multiplied by negative 1 is equivalent to 4. This one is result identity. Okay, ada soalan apa-apa soalan ke? Tak. Saya tunjuk lagi sekali untuk result identity lah, sebab ada yang tak ni. Untuk visual identity, kita ada A, X plus B, Y, kemudian tu GCD, AB. More importantly, you can find X. Okay. Saya tengok ya. Okay, and then kalau kita tengok 39 9 sama dengan 2 kali 15 tambah 9. Sekejap. Tu kita ada 15 sama dengan 1 kali 9 tambah 6. Lepas tu kita ada 9 sama dengan 1 darab 6 tambah 3. Kita ada 6 sama dengan 2 kali 3 tambah 0. So kalau kita tengok 3 sama dengan berapa kali 39 tambah 0 kali 15. So kita tengok equation from Excluding algorithm 963 lah. Dan kita cari reminder. So kita start 9. Kita start dengan 9 ni. Jadi kita start 9 sama dengan 39 tolak 2 kali 15. Okay, dapat 9 lah. Okay, lepas tu kita start dengan 6 pula. 6 sama dengan 15 tolak 1 kali 9. Lepas tu kita start dengan 3. 3 sama dengan 9 tolak 1 kali 6. Okay, kita buat backward substitution. Jadi kalau kita buat backward substitution, kita akan dapat 3 sama dengan 9 tolak 1 kali 15 tolak 1 kali 9. Okay. Kemudian kita akan dapat 9 tolak 15 tambah 9 sama dengan 2 kali 9 tolak 15. Lepas tu sama dengan 2 kali 39 tolak 2 kali 15 tolak 15 sama dengan 2 kali 39 tolak 5 kali 15. So kalau kita nak check 2 kali 39 So kita check 2 kali 39 tolak 5 kali 15, kita akan dapati bahawa 78 tolak 75 sama dengan 3. Betul tak jawapannya? Sama kan? Yang ni untuk kita panggil dia sebagai uh, Bizarre Identity menggunakan Euclidean algorithm lah. Kita buat dia backward lah. Okay, in general case kita akan dapati bahawa jika A dan B adalah integer, not semua tidak sama dengan 0, and the highest common factor is D, then there are integers V and W such as AV plus BW equal to D lah. Okay, so dekat sini kita ada A 39, B 15 and D adalah 3, dan we calculate that V 2 dan W adalah negatif 5 lah. Okay, yang ni kita A kita dapat 39 tadi. Yang A ni 39, A ni 39, B ni 15. Okay, kita dapati A X plus BY sama dengan D lah. Okay, D. Okay, D ni kita dapat 3 tadi kan. Okay, 3. Okay, kemudian kita calculate tadi, kita dapat V A, lepas tu V dengan W kita dapat 2, dan W kita dapat negatif 5 lah. Okay, sometimes it also call it as a Bizot lemma lah. Lemma or identity lah. Contoh lain kalau kamu tak faham lagi, saya bagi satu lagi contoh. Kalau ada yang tak faham lagi. Kita ada GCD ED sama dengan EU plus BV lah. Kita nak cari U dengan V ni. Jadi kita ada GCD. Contohnya kita ada 4 dengan 16 lah. Sama dengan 4. Jadi ini sebagai A, yang ni sebagai B lah. Jadi kita nak buat 4 sama dengan 4 1 plus 16 kosong lah. 4 sama dengan 4 tambah kosong, 4 sama dengan 4 lah. Jadi 1 dengan kosong ni dipanggil sebagai Bizot identity. Okay, saya teruskan. Okay, kita ada 4 sama dengan 45 tambah 16 itu 1 sama dengan 4 sama dengan 20 tolak 16 sama dengan 4 lah. Dia mesti any 20 non-zero integer A and B lah. Okay, yang kita dah tengok tadi untuk wizard identity. Okay. Untuk wizard identity tadi, dia kata apa? If A and B are positive, then there exist S and T. Yang ni kita gunakan A and B. Such that GCD A and B is S A plus T B lah. S dengan T ni adalah dia punya wizard identity lah. Okay. Boleh? Okay.